Hi, this is Daniel Hens, meteorologist with the Flood Control District of Maricopa County. I'm here to talk about the 2017 official Monsoon Outlook published from the Flood Warning Branch. Let's dive right into it. So when is the monsoon? The season officially runs from June 15th to September 30th. Even though that's the official start and end times, most locals here know that the typical onset, or when storm activity and subsequent rainfall begins, typically doesn't start till a few weeks after that. On average, that's around July 7th. We used to measure that by getting 3 consecutive days with dew point reading of 55 degrees or greater. In terms of rainfall stats, average season rainfall at Phoenix Sky Harbor is 2.71 inches. That accounts for roughly 30 to 40% of the yearly total. Our wettest season was 9.56 inches in 1984, with the driest season at 0.35 inches in 1924. Overall, we typically see around 11 days with rain at the airport. Last year, we had 2.49 inches at the airport, and that's considered near normal. Now, if we average all the rain that accumulated across the alert gauges spread out around the county, we had 2.63 inches, and that's right around normal, which is 2.96. So again, similar result. All right, here's a quick refresher on the North American monsoon. The name monsoon simply means seasonal wind shift. In Arizona here, during the fall, spring, and even over the winter, typically winds flow from the southwest or west to the east or east-northeast. During the monsoon, we get this change where the winds shift out of the south-southeast. The main mechanism behind that is what we call the monsoon ridge, a ridge of high pressure that slowly moves north during the June and July before centering somewhere in the desert southwest. Clockwise flow around that high pressure center helps draw mid and upper level moisture from central Mexico and even the Gulf of Mexico. Intense heating across southwestern Arizona forms what we call a thermal heat low, and that thermal heat low helps draw moisture up out of the Gulf of California as well as the Pacific. It's important to note that that thermal heat low isn't necessarily always the driver for low-level moisture. Sometimes we get tropical systems, tropical disturbances, or even disturbances out of the Pacific Northwest, all of which can do the same thing. When we've reached the critical moisture levels, we get enough daytime heating, we tend to see thunderstorms forming over the higher terrain first. So that would be the Mogollon Rim or White Mountains or the Sky Islands of southeast Arizona. Then as we get later into the season, sufficient moisture has occurred across the lower deserts, we tend to get thunderstorms there as well. Here's NOAA's Climate Prediction Center 3-month summer outlook for 2017. What you're looking at here is a 3-class forecast that's giving you a probability of above, below, or normal when it comes to a particular variable. So in this case, above normal temperatures are favored for this upcoming summer. When it comes to precipitation, we're seeing equal chances of above, below, or normal rainfall during the monsoon. Again, this is a 3-month average, so unfortunately it doesn't tell us a whole lot about what to expect on any given month, week, or even day. So let's delve a little bit deeper here. What's going on with ENSO, or the El Nino Southern Oscillation? Well, currently it's in its neutral phase. And if you look at the image on the top right, you'll see sea surface temperature anomalies across the equatorial Pacific. The warmer colors, so the yellows, oranges, and reds, represent above normal sea surface temperatures, and the blues represent below normal sea surface temperatures. And again, if we look across the equatorial Pacific, where I have my cursor here, we can see in general, we're right around normal, and this is representative of the neutral phase. Now, if you look at the image in the bottom right, this is our consensus forecast from the folks over at CPC. And they're saying that neutral conditions are favored into this upcoming summer, fall, and even winter, with a slight chance of possible weak El Nino forming. The ENSO climate signal is much weaker in the summertime, meaning that other weather drivers are much more important when it comes to rainfall. To emphasize this a little bit more, let's take a look at the typical precipitation distribution for Climate Division 96. This is provided by NOAA NWS. So if you're wondering where is Climate Division 96, you can look in the little map on the top left, and basically all of Maricopa County, parts of Pinal, Yuma, as well as La Paz counties, and even a little bit of Yavapai County are all included. What we can see in these distributions here is that regardless of whether we're in a La Nina year or the distribution on the right, neutral, which is in the center, or El Nino on the left, there's lots of variability, but there's no real strong tie to greater precipitation or less precipitation. So let's go and take a look at monsoon ridge variability. The image you're looking at here is a 500 millibar geopotential height covering the last 30 years, or climatology. Higher heights are represented by yellows, oranges, and reds, with lower heights represented by the blues and then purples. Higher heights are associated with high pressure, and here we can see across Arizona, New Mexico, and Texas, this focused area, or what we would say the monsoon ridge. Remember, wind flows clockwise around this high, so this is putting us in a favorable area for southeasterly winds, increasing moisture, and chances for thunderstorms. Now let's take a look at the global sea surface temperature anomalies. We're going to focus over the Pacific Ocean here. Again, warmer colors, the yellows, oranges, and reds, mean warmer than average sea surface temperatures, while the blues represent colder than average sea surface temperatures. Let's look at the Central North Pacific cold pool. So research tells us that when this cold pool is present, the monsoon ridge typically tends to be pushed a little bit farther to the south and to the east, or what we'd call maybe a southern Great Plains high or even a West Texas high. As I mentioned before, this can tend to put us into southwesterly flow in Arizona, which could limit the amount of moisture and may make it a little more unfavorable for thunderstorms across Arizona. But then again, this also opens us up to the possibility of tropical systems. Now let's take a look at that second box that's centered over the Gulf of California. So here what we're looking at are sea surface temperatures from the Gulf of California. The warmer the temperature are associated with the warmer colors, so the greens, yellows, and oranges, and then cooler temperatures are by the blues and purples. Let's focus in on the Baja California, the southern part and central part. Here, the key isotherm we're looking for is the 26 degrees Celsius isotherm. And as we can tell, pretty much all the waters in this part of the Gulf have already exceeded that amount. And that's good, because that's what helps propagate the monsoon ridge further north, and again, giving us that extra supply of low-level moisture. However, now let's focus on the northern Gulf of California, as this is the most important piece. Research has told us that as soon as the sea surface temperature average gets above 28.5 degrees Celsius, approximately 80% of the rainfall that we experience across New Mexico and Arizona comes after that point. As you can tell here, on average, we're around 25 to 26 degrees Celsius in this region, and that means we still got another couple of weeks to go to warm up. Now we're looking at the western U.S. precip for the previous winter. And here what we can see is a lot of rain and snow during last winter. Whether you're in the desert Southwest, whether you're in the Great Basin, or even the Rockies, it was quite a good year. You can also see here up in the Pacific Northwest, designated by the red circle, drier than normal conditions. Now why this is important is because research has shown drier monsoons tend to follow a wet winter, especially when it's across the desert Southwest, Great Basin, and Rocky region, along with the drier Pacific Northwest. The line of thinking behind that is that all the added precipitation during the winter months changes soil moisture conditions, as well as the vegetation. Furthermore, snowfall, for example, in the Rockies, can limit the amount of spring and even summer insolation on the higher terrain areas there, which are critical when it comes to getting the monsoon ridge to move north. Now let's take a look at the East Pacific Hurricane Outlook provided by NOAA's National Hurricane Center. The image you're seeing behind there may be familiar to a lot of you. This is from last year in September with Hurricane Newton. Many folks that live in Southeast Arizona remember this, because there were torrential rains that fell from the Tucson area, east in the Sierra Vista, straight into southwestern New Mexico. It's quite an impactful rain event for all those folks, again, living in the area. So what about the outlook? So the folks over there are saying we're looking at a normal to above normal season. What that typically means is anywhere from 14 to 20 named storms, 6 to 11 hurricanes, 3 to 7 of which may be major. This is really comparable when we take a look back at 2016, which was considered really active. Again, all it takes is one of these tropical events and just the moisture from it to really help enhance our rainfall during the second half of the monsoon. Some final thoughts. We took a look at the forecast from the Climate Prediction Center. Again, that's calling for above normal temperatures and then equal chances for above, below, or normal precipitation. When looking into some of the other predictive factors, we're tending to see this bias towards a later possible onset to the monsoon and then a drier than normal start. So we're talking about July. Now, the other thing that we may be noticing or taking from this is that tropical systems are definitely going to be the main wild card for the second half of the monsoon. It only takes 1 or 2 heavy rainfall events to reach the historical monsoon rainfall quota. That 2.71 inches that you see at Phoenix Sky Harbor, it doesn't take a whole lot to get to that amount. We can get that over a couple of days or even in one event, similar to what we saw in 2014. You also want to remember that any location in the Phoenix Valley, or South Central Arizona for that matter, is subject to flooding or flash flooding problems if enough rain falls in the proper duration. Now is the time to prepare, and there's lots of information available. I want to take one quick moment just to state that even though we're calling for maybe a late and drier start to the monsoon, we will still have daily thunderstorm issues, things that we typically see every monsoon season.